Right, here we have a question on horizontal circles. It's Edx M3 January 2010, question 6. It's a question about a car going around a bend on a track. Firstly, a level track, and then secondly, a banked track. So make sure you've read the question carefully, and then when you're ready, resume the video. Right, part A. It's a horizontal circle, radius 120, and you're told the maximum speed at which the motorcycle can be ridden around the bend is 28. So I've drawn a diagram showing the situation where it's going at its maximum speed. That must imply that at this speed it's on the point of slipping. So slipping would mean that friction is limiting on the point of slipping. It's the frictional force here that is providing the force towards the center for this circular motion to take place. Vertically, R just equals mg. But horizontally, we've got mu r towards the center then. Resolve horizontally towards the center. We've got, use blue, that's better. We've got mu r, the force towards the center is mv squared over r. So, since r is equal to mg, by resolving vertically, and we know v and we know r, we can just plug them in now. Mu times mg is equal to m times 28 squared over 120. M's cancel, and mu works out to be, well, they want us to show it comes to 2/3, so hopefully it will. 28 squared over 120 times 9.8. And it works out, yes, check that, it comes to 2/3 as required. That's the squared, I don't know what happened there. Right, 28 squared over 120g. So we've shown the coefficient of friction. 6 marks for that, that's quite generous. The second part of the question, I've drawn a diagram for it already, is trickier. There's 8 marks. This time the track is banked, so the track's at an angle. This means that it gets more complicated in terms of the equations, because the forces that contribute towards the force towards the center of the circle are a component of the frictional force and a component of the normal reaction. Right, this time the maximum speed is 35. So same diagram as before, effectively with friction being limiting. So friction's 2/3 r, and the speed now is 35. So resolving, as usual in horizontal circular motion questions, we resolve vertically and horizontally towards the center of the circle. Vertically, we get r cos alpha equals mg plus 2/3 r sine alpha. Now we don't know alpha, we have to find the value of tan alpha. Horizontally, r sine alpha plus 2/3 of r cos alpha. Those are the two components of forces towards the center. That's equal to mv squared over r, which in this case is 35 squared over 120. Now, we've got two unknowns there, r and alpha. We're interested in finding tan alpha. So, if we tidy these equations up a bit, if we multiply by 3 and just tidy them up, the two equations turn into 3r cos alpha minus 2r sine alpha equals 29.4. I actually worked it out, so it doesn't have as many letters to worry about. And underneath that, 3r sine alpha plus 2r cos alpha. These are the same equations. I've just multiplied through by 3 and worked out some of the terms, equals 30. Oh, there's an M, the 29.4 M, and this one works out as 30.625 M. Now, M was something I brought in, so hopefully the M's will disappear, and I'll show you why that happens now. We're after tan alpha, and we've got this pair of equations. The trick now is to divide one by the other. So effectively, if you put one equation over the other and take R out, these two equations become, check this by pausing the video, okay, two things have happened there. We've had the R's have cancelled out and the M's have cancelled out. That's 625 there, if it's unclear. Now, how do we find tan alpha from that? Well, divide top and bottom of that fraction on the left, divide right through by cos alpha. And if we do that, the equations become 3 minus 2 tan alpha over 3 tan alpha plus 2 is equal to, and actually 29.4 over 30.625, that, when you put it in the calculator, it comes to 24 over 25. Well, we're getting there. This is an equation now for tan alpha. So we need to multiply through, cross multiply, and we end up with an equation for tan alpha. I'm running a bit short of room. We get, I'll just call tan alpha t if I can here, just to keep the space down to a minimum. 3 minus 2t equals 24 into 3t plus 2. Right. Just skipping one more line where you've got to expand the brackets and collect up the t's, the tan alpha. Tan alpha works out to be 27 over 122. That is alpha 27 over 122. I've got this right. Right, so tan alpha is 27 over 122. That's the correct answer. And that's 8 marks. Rather a nasty question, that, because basically it's the pure maths sorting out the finding the tan alpha. The marks, well, for the first part of the question, 6 marks. There was B marks, in other words, marks for just seeing the statements, for the mu r and the mv squared over r. There. Then there was an m1a1 for the mu r equals mv squared over r statement. And an m1a1 for working it out, putting the numbers in and getting the correct value of mu. And that's the 6 marks for part A. For part B, where we had a total of, 8 marks, there was m1a1 twice for the resolving. So an m1a1 for resolving vertically, and an m1a1 for resolving horizontally. then there was 3 method marks and just 1 accuracy marks, reflecting the fact that it was fairly sort of tricky working out. So I'll just say M3 A1. Right. 3, 4, 5, 6, 7, 8. That's the 8 marks for this. Okay, thank you for listening.